about it, some of you said, well, but this is when it hits the ground. It should be 0. Well, no. So I'll give you an example. I should use this. I want to use something heavier. Ah, I know. Will someone volunteer? Mitchell, come here. Okay. So turn and face the class. Now stick out your foot. I'm going to drop this on his foot. No, put it down. I'm going to drop this on his foot. Is that going to hurt? Yeah, I'm not actually going to do it.
Do it.
Okay?
Do it.
So when this crate falls to the ground and hits Mitchell's foot, does it have 0 velocity? Heck no. It's got a lot of velocity, and that's why it hurts, because that velocity, it's been accelerating down from its max height, accelerating down to a new velocity, and it's going to hurt.
So VI can't equal 0.
No, not for that. No. Thank you.
Good job, Mitchell.
So when we think about VI, we're thinking about the velocity that the object gets shot out at. It is not 0, right? It is moving. As well with VF, we cannot think about VF at this point being 0 because it has movement. After say, this crate hits Mitchell's foot, his foot will absorb that impact, and later, after impact, it will have 0. But at the point of impact, there is velocity. You see the logic of that now? So that is why, and then mathematically, if it's at the same horizontal spot, VF is equal to negative VI. Because the height that it goes to accelerate, it accelerates at the same speed down. And it's the same height. So if I go up this much and it comes down this much, it's going to be exactly the opposite. You see? That's why it's VI is here and VF is negative VI at this point. Now, at this point, VY, meaning my vertical velocity, is equal to 0. Okay? That's at max height. So this is max height. And this is when time is a half. Okay? So at time half, that VY, so the vertical velocity, is 0. So sometimes in questions, when you're trying to figure out max height, for the formula, you will be setting this to VF when you're just dealing with a vertical component. Okay? So I give example in a minute. But when we think about these questions, you always need to break it down into, am I thinking about horizontal motion or am I thinking about vertical motion? Because they're different. So here, where we have VI, there is horizontal motion, okay? And then there is our vertical motion. And we're actually going to draw the vertical a little bit bigger. Okay? And the hypotenuse of it is this overall V net. As it goes up closer to V max, my vertical vector gets smaller because I'm slowing down. But horizontally, it always stays the same. Okay? Vx always stays the same. So this arrow should be the same size regardless of where it's at. Vx is always, always, always the same in these questions. Okay? Vx. So these are our Vx's. But Vy is what changes. So here, you know, I've got a good Vy. But here it's starting to slow down because of the acceleration due to gravity, that Vy is starting to slow down. Then right up here, Vy is 0. Okay, that's my vertical component. It's 0 at that point. But horizontally, it's still moving. So we have something moving horizontally. If I throw this, it still has the same horizontal component, right? It's still always moving this way. And it moves this way at the same motion because nothing else is affecting it. It's still moving horizontally, right? It's always moving horizontally. But the reason why it was higher and then it was lower was because of gravity. Huh? Where's my... Okay. So if we write in our Vy's on this side, they go down. And they get even bigger on the last vectors because the acceleration is pushing it even more. It accelerates, right? So the velocity should be bigger at the very end. If this was a cliff and it keeps going, it's going to accelerate even more. That's why, you know, if you just jump into the pool, like right here, say the pool's right there, it's like, woohoo, yeah, go into the pool. But say you jump off of, you know, a 200-meter diving board.
Oh.
The water's going to hurt because you have increased velocity. Because the acceleration due to gravity has pushed you even faster. Right? You know that. You go faster the higher up you go. Okay. Oh, I'm so excited. This is great. I hope you understand it more. Okay. I'll go through a little bit more and maybe you will. So when we think about our x component, oh shoot, where's my notes? Oh, I found them. Okay. So when we think about our x component, this is always uniform motion. Moving horizontal. So it's always moving horizontal across. Always, always. And it stays the same. Uniform motion stays the same. So that's why with the x component, my horizontal component, I only ever use v equals d over t. Because nothing is affecting horizontal movement. It's horizontal. It just stays horizontal. So it has the same horizontal velocity as of when I went up and when it went down. Same horizontal. Y is uniform acceleration or accelerated motion due to gravity. Therefore, with your 3 little dots, therefore, use any acceleration formula that works. Which one is always the same? The x or horizontal component is consistent throughout the entire projection. What happens at impact? There is motion at impact. That's why it hurts And we can say VF is equal to negative VI when landing at same height as initial. So just like I said here, we assume that this VF is straight across from VI. In Physics 30, we'll do more complex ones that deal with projectile. But for right now, we'll just assume that. And that's all we'll work with. What happens after impact? Well, we don't calculate that, but whatever is impacted will interact with object to resist object's motion. So like water is not going to resist your motion too much, but you will feel it. Say you jumped off a 200-meter diving board into brick concrete. That's going to resist your motion a lot more than water, right? Yeah, okay? So depending on whatever it's run into will depend on that. But we don't worry about after impact in terms of calculations. We just think about what's its final velocity. Yeah, yeah. Okay, so let's do one example and then you do one practice problem. And then it's study time. What? Do you need a Kleenex? Okay. That's okay. Projectile motion? Something? Okay, so a paintball is directed at a target and is shot at an angle of 25 degrees. If the paint splats on its intended target at the same height from which it was launched 3 seconds later, find the distance from the shooter to the target. So, our diagram, we assume it starts here and it's at the same height when it lands. So regardless of this, if it's from like up here, like you're shooting, say, a paintball gun, and it lands, say, if Morgan was standing, it lands right on his chest or something, doesn't matter. We just say it goes from the same to the same height, okay? So it's being projected at 25 degrees. We are asked to find this distance, this horizontal distance. This is, I'm going to say this is dx, because that's all about horizontal motion. That's my dx. And I'm just going to kind of write in all my information here to help me make sure that I'm keeping everything on track. This would be my dy. At the top of dy, my vy is equal to 0. And it's at t is a half. So I'm just kind of getting all my information in order here. Okay, so let's split up our information into horizontal, which is uniform motion, just to remind you. So we only use v equals d over t. And vertical is uniform accelerated motion. So I need to use a is equal to negative 9.81 meters per second squared. So when you're setting up a projectile type question, I would advise that you always do this, that you write out your horizontal, vertical, immediately write in your a, and write in v equals d over t for your horizontal. Because regardless of what your question is, you need to set that up first. Okay? You need to know that that's what you have. Okay. So, I need to find out my velocity, my initial velocity, first before I can really do much. Yeah, okay? So, in order to do that, so I'm trying to find my VI of my vertical. So I don't really know like any of my horizontal information. Oh, I know my time. Time is 3 seconds, and that's consistent for both. Time is the same. Now, right when it's launched from the paintball gun, the distance is 0 because it hasn't gone anywhere. It's like right as the paintball is being launched, we're going to just set D to 0 so that we can find our VI. So D is equal to VIT plus half AT squared is the acceleration formula we're going to use to find our VI. So my D is set to 0, so I'm going to rearrange this. So I have instead, now I'm going to take this to the other side, half AT squared is equal to VIT. I want to get V all by itself, so I divide by T and divide by T. I already have a T here, so really that just crosses out my T squared. So now I have half AT is equal to VI. So negative half times by negative 9.81 meters per second squared times by 3 seconds. Oh, and I also know my D, never mind, I won't tell you guys that, is equal to VI. So VI is 14.7 meters per second. So I'm going to go back to my diagram and write that in. So VI is 14.7 meters per second. So then I'm going to go over here and say, well, my VF then must equal negative 14.7 meters per second. Just filling in information. All right. So, what is this VI? This VI is in what category? Vertical. So it is my vertical vector. So I'm going to go back to my initial information here. So this was kind of my first step. Now my second step is to draw out my initial vector, 25 degrees. It has both a horizontal and vertical component. I found this component is Vy for here. So Vy is 14.7 meters per second is equal to Vy. I'm asked to find the distance from the shooter to the target. So I need my horizontal velocity to find out my answer. So I need to look for Vx. Well, I can use trigonometry to do that. So I can set, so I'm going to use tan opposite over adjacent. So tan of 25 degrees is equal to 14.7 meters per second divided by Vx. So tan 25 degrees, multiply that. So 14, we go 14.7 meters per second divided by tan 25 degrees to get Vx. Okay, so my Vx then is 31.56 meters per second. So now I can put that information here. Vx is 31.56 meters per second. And also, I just want to clarify one thing. This Vi is the Vi like Y at that spot going up. And this Vf is the Vf like, that's the Vfy. So that's going down at that spot. Because that was our vertical information. Okay, so now D is equal to V times T. D is 31.56 meters per second times by 3 seconds. So D is equal to 94.6 meters. So, this is obvious.